For the fourth notebook of this Copernicus Marine Service training session on the Baltic Sea and on the sea ice, we will look at different parameters than the sea ice in the region. That is to say, the temperature and the salinity profiles from the CMEMS model, which of course strongly depends on the sea ice conditions as well during the winter season. So first, we import the Python libraries that will be used to handle the data and to plot the variables. So as usual, Shift press Enter, or this button here, run the selected cells and advance. We will use the model analysis and forecast product, the daily product, the same file as the one we used in the previous notebook. So a file that was downloaded from the CMEMS FTP interface for the 5th of March 2018. And if we explore the content of this file using the Open Dataset function from the Xarray library, you can see that we have not only the sea ice thickness and the sea ice concentration variables, but also the temperature and the salinity, which depend on the depth. So we are going to plot the temperature and the salinity profiles from this model product at the 3 points that we have defined here, which are the same one as we defined for the ship route in the previous notebook. So point 1 is located in a free water region, and point 2 and point 3 in regions with sea ice. And point 3 is located in the Bothnian Bay, which is characterized by very low salinity values. So first we define the path and the name of the file that we are going to look at and the variables we want to extract, and we create a folder where we will store the plots. So validate this cell, and then we open the dataset and we store its content in variables specifically for the temperature and for the salinity, and also for the latitude, the longitude, the time, and the depth. And then we plot, we are going first to extract the information, so the temperature and the salinity information at the 3 points that we have defined on the map. So here you have the coordinates of these points, and we use the self function to select the grid points in the temperature and the salinity variable that are the closest to this 3 fixed points. So here it is, and you can see that we display here the content of the Varti point variable. So it contains the temperature for one time frame, because we only have one time frame in this product, for the 25 depth levels, and for the 3 latitude and longitude points that we have defined. And now we can plot this information. So we're going to plot the data as a function of the depth, to have the depth profiles. So here you have for each point in color the temperature and the depth here, and the salinity for this plot here. And we can see the different water masses depending on the point location. So you can see that for the point that is located in the Bothnian Bay, the salinity is very homogeneous for the whole water column, whereas for the point located in the Baltic proper, the salinity has a different, there are different water masses depending on the depth, and the same for the temperature, as you can see here. And now we can also plot this information on the temperature and salinity diagram. So the salinity as a function of the temperature for each of these points. So we do it here, and we are going to use different marker types for each point. And so here we plot the depth also as a function in color. So red is for the surface, and blue is for the deepest points or deepest levels in the model. And so here we can see the different behavior of the water masses again. So 0.3, very homogeneous in salinity and with the variation of the temperature, and 0.1 and 2, which have relatively close behavior. So of course you can do this kind of diagnosis anywhere in the basin by just extracting all the points. That's it for this training and for this tutorial. This was the last video for the notebook 5 and notebook 6. You can refer to the first and the second videos, because we compare the model and the observation products using the same kind of diagnosis and maps. So thank you for your attention, and I hope you will enjoy using this sea ice CMEMS product. Thank you.